Good morning, ladies and gentlemen. Sorry I could not be here today. I am at a workshop. Our lesson today is going to be on the natural exponential function. And then, if there's any time, work on the assignment, which will be due when you come on Monday. Don't forget the Mastery Quiz number 12 is on Monday. All right, here we go. This should take us about 20 minutes. Chapter 7.3. All right, first of all, a little history lesson here. The history of mathematics is marked by the discovery of special numbers such as pi and I. Another special number is denoted by the letter E. The number is called the natural base E, or the Euler number, after its discoverer, Leonard Euler. All right, the expression 1 plus 1 over n to the n power approaches e as n increases. All right, so what I'm going to do is I'm going to demonstrate with the calculator, and if you want to do this as I do it on the calculator, that's fine. Otherwise, just watch. Before I do anything on the calculator, however, I do want you to note that this 1 plus 1 over n to the n looks very close to something we learned earlier in this chapter. If you remember the compound interest formula, the amount equals the principal times 1 plus r over n to the n times t power. Okay, so hopefully you recognize that we've got our 1 plus, okay, we've got an r here, but over here we've got a 1. And we've got the n underneath closed, and then we've got the n without the t attached. So you can see how that is closely related to the compound interest problems. And we're going to look at that again when we get close to the end of the lesson. All right, so what I'm going to do is I'm going to take my calculator and I am going to type into my y equals parentheses 1 plus 1 divided by, now obviously I don't use n, I have to use x in my calculator, so x, close it, and then I'm going to raise that using my exponent key to the x power. All right, so I'm only typing in that expression. Now I'm going to go to my table. And again, this is going to be a special number. Okay? I'm going to start, I'm going to go ahead and begin at 0. Okay, just so you can see this a little bit better. So I'm going to start at 0. You'll notice 0 is an error. Okay? That's because we can't divide by 0. So I'm going to scroll down, and I'm just going to keep on scrolling for a while. Okay, probably about almost a minute. I'm just going to hit this button a whole bunch of times, and we're going to watch the y column and see what is happening. Okay, you notice right now it's at 2.67. Okay, it's still going 2.6. Now it's at 2.68. Okay, and it's still going. Okay, I'm going to hit it a bunch more times. Okay, it's going up slowly. Now it's at 2.69. Still going up. It's not changing very much. Okay, let me hit it a bunch more times again. Okay, if you think about the last couple of lessons, remember when we graphed some of those equations, how they approach a certain number, but they do not cross that number? Okay, well, that's what's happening here. It is approaching a certain number. Okay, and it's not going to cross it. It's kind of like having that boundary line there. Okay, you'll notice now it's at 2.7. Okay, and we could keep going. And eventually, it's going to get, okay, I don't think it's going to take too long to get there, so I'm going to speed this up a bit. It's going to get to 2.718. If I kept going, it would approach 2.718, and it would not go any further. That, ladies and gentlemen, is what the E represents, the Euler, 2.718. And let's take a look at the calculator. There are two places on the calculator that you can find this. The first place is above the divide sign. Okay, if you hit second and hit the divide sign, first let me get out of this screen, second and the divide sign, it'll give you the E. That's one place you can find it. And if I hit enter, there it is. It goes a lot further than 2.718. Another place you can find it is on the left side above, it's close to the 4 button. It's above the LN button. So if I hit second, the LN button, you'll notice it automatically puts an exponent on there. So if I just put a 1 on there, again, it's 2.71828, All right, so this is another special number that we are going to use. All right, continuing. So simplify natural base expression. So we're just going to run through some of the basics that you already know, but now we're going to be using the E, base E. For example, if we have e to the 9th times e to the 5th power. Again, this is the base E. They are the same. So apply your rules of exponents. So we add those two together. So e, that becomes 14. So e to the 14th power. All right. Looking at the next one. If we have something like this, 60 e to the 8th over 12 e to the 3rd. All right. Now, the 60 and the 12, okay, you just do that normally. 60 divided by 12 is 5. Then, using your rules of exponents again, we've got the e to the 8th and e to the 3rd. Okay, what do we do there? Subtract. So we have e to the 8, take away 3, is 5. So 5e to the 5th power. That is your simplified answer. All right, moving on. One more of these. Let's say we have in parentheses negative 10 e to the negative 5x to the 3rd power. All right, well, the rule here is that exponent of 3 belongs to everything that's inside. There are no plus or minus signs here. So I'm going to rewrite this first like this. Negative 10 to the 3rd power, because the 3 goes to the negative 10. And also it goes to the e to the negative 5x power to the 3rd power. Now, if I type negative 10 to the 3rd power into my calculator, I'm going to get negative 1,000. And then e, now remember what we do with exponents here. We've got an exponent to an exponent. We're going to multiply. So that would be negative 15x. So that is my simplified answer. So that was just a quick review of our 3 exponent rules, but using the base E. All right? Moving on. Evaluate natural base expressions with the calculator. Okay? All you have to do is type these in. For example, if I have e to the 6th power, so I showed you the 2 places on the calculator already. Okay, I'm going to pick the one with the exponent, so I'm going to hit second and then the LN button on the left side. And all I have to do is put a 6 there and hit enter, and voila, I have simplified. Okay, I'm evaluating that expression, and that becomes 403.429. Okay, that's all we had to do. 403.429. Okay, one more. If we have e to the negative 0.28 power. Do it exactly the same way. Go ahead and do second ln, negative 0.28, and hit enter, and 0.756. We're going to round it 3 decimal places, 0.756. All right, so that is to evaluate natural base expressions with the calculator. All right, now, again, you do not have to have graph paper for this. You can do this freehand. We're only going to do one of these. Okay, and it's exactly the same thing that we did in the last 2 lessons. If we have y equals 2e to the 0.5x power, okay, we're going to make a table. Now, unfortunately, here you are going to have to deal with some decimals. You're not going to have nice numbers. Okay, so I'm going to go ahead and go to my y equals. I'm going to type this in, 2e to the 0.5x power. I'm going to go to my table. Okay, now I'm going to quickly go back and just go to my table set because I want to go back to 0 here. I don't want to take time scrolling. Okay, back to my table. There we go. Now I'm actually going to scroll up a little bit. Okay, and I'm going to start with negative 2. Okay, it's a judgment call on where you want to start this. Maybe you want to go ahead and look at the graph first. So remember zoom 6. This is what the graph looks like. And how about that? It's an exponential growth. Okay, e is bigger than 1, so it should be a growth. It should not be a decay. 2.718 is bigger than 1, so it's a growth. Again, the only thing is you don't have nice numbers to work with. So here are some of the decimals I'm going to go ahead and graph. Okay, I'm going to make my table. So I've got the negative 2 and 0.7, negative 1 and 1.21, 0, 2, that's the only nice one, 1, 3.3, 2, 5.4. Okay, that should be enough. So negative 2.7, that's up just a little bit. Negative 1, up 1.21. 0, 2. 1, 3.3. 2, 5.4. Okay, just a rough estimate. And then it goes in both directions, a curved line going up and a curved line going to the left. Okay, so nothing different there. It's exactly the same as chapter 7.1. So if I put on here e to the negative 2 times x plus 1 plus 3, what's that going to do? Well, it's going to go up 3 units, and it's going to go left 1 unit. Okay? Don't forget about range and domain. Going back to the original. Okay? First of all, we have the domain has not changed yet. The domain is still going to be all real numbers. That goes for both of them. The range for this one, again, you see that it's approaching 0. So y, and it's going up, so y is greater than 0. On this one, okay, since it went up 3, the range is going to be y is greater than 3. Again, the line would be going up. If you graphed it, you would see that the line is going up. All right, and then the last thing, as mentioned earlier, the compound interest looks very, very similar to the 1 plus 1 over n to the n power. Okay? So what we say is the compound interest formula approaches the following formula. Okay? So this is approaching this. Think about R. R is your rate. Okay? And the closer and closer R gets to 1, eventually it will become 1. Okay, that's why the R can be a 1. And then our N is how many times, and our N times T is how many times over those number of years. Okay? So the compound interest formula approaches that formula, 1 plus 1 over n to the n power. 1 plus 1 over n to the n power. All right, so what's so special about that? Well, this is what I was mentioning earlier. Okay, we've got what's called continuously compounded interest. When interest is compounded continuously, the amount A in an account after T years is given by this formula. And we call this formula PERT. A equals P times E to the RT power. Please make note that the R and T are exponents. They are powers. Now, whoa. Where did that come from? Okay, remember, ladies and gentlemen, that 1 plus 1 over n to the n approaches E. 2.718. But we're not going to use 2.718. We're going to use E in its place. All right, so super easy formula to use. So on the next page, we've got a deposit of $3,000 in an account that pays 3.5% annually in annual interest, compounded continuously, and this will be on your mastery quiz on Monday. What is the balance after 3 years? All right, so I'm going to write the formula again. A equals P times E to the RT power, PERT. So the amount equals, the principal is 3,000 times E. The rate, okay, remember we changed that to a decimal, 0.035. Okay, now I'm going to use parentheses here, 0.035 times T, well, T is 3 years, so I'm going to put times 3. All right, so take your calculator, go back to your home screen. All right, sorry if there was a funny glitch there. My calculator froze for a moment, so let me begin that again. All right, so we're going to type in 3,000 e to the 0.035 times 3 power. Here we go. So 3,000, and then we're going to use the e, parentheses, make sure you use parentheses, 0.035 times 3, close it. And if the interest is compounded continuously, okay, every second, every millisecond of every day, that's how much money you would have in your account after 3 years. $3,332.13. Super easy formula to remember. You only need to know the principal, the rate, and the time. You don't have to worry about n at all. All right, hopefully that was enough. You took good notes. If you didn't, don't forget the notes are on Moodle, and the worksheet that you are going to receive is due on Monday. Have a good day, folks.